All right, let's dive right in. We're all excited about artificial intelligence, but there's a hidden danger that comes with the incredible amount of data it needs to work. We're talking about your privacy, and a brilliant mathematical tool that's been designed to protect it. So, that brings us to the most important question of all.
It seems like a simple question, right? But the answer has huge implications for every single one of us. When we feed AI models our information, and I mean everything from our Google searches to our private medical histories, we're basically trusting that it'll all stay locked away. But can we really be sure?
And yeah, there's the catch. The honest answer is, not always. The truth is, these AI models aren't perfect digital vaults. They have this one specific vulnerability that can actually expose the very data they were trained on, and that creates a massive risk for all of us.
Okay, so how does this even happen? How can an AI just leak your data? To really get it, we need to look at what's going on under the hood, at the core of the problem, what we can call the AI data leak.
The fancy term for this problem is memorization risk, and you can think of it like this. When an AI model is learning from billions of data points, sometimes it doesn't just learn the general patterns. It actually memorizes specific examples, word for word. So, if your medical record happens to be in that training data, there's a real chance the AI could just spit that exact record right back out later on.
And what's really scary is the kind of stuff that's at stake. We're not just talking about anonymous stats here. Clever attackers can literally pull the most sensitive parts of your identity straight from the model's memory. We're talking your name, your address, even your bank account number. It's a direct line into the data it was trained on.
Okay, I know that sounds pretty terrifying, but don't worry, this isn't all doom and gloom. Researchers have come up with a really brilliant solution. So it's time to introduce the hero of our story, a concept we can think of as a privacy shield.
This solution is a powerful mathematical idea called differential privacy. Now, the math itself can get a little heavy, but the core idea, it's actually beautifully simple. Just think of it as a protective shield that we wrap around the AI's entire training process, making sure our personal data stays private.
So how does this privacy shield actually do its thing? How does it work its magic? Well, let's dig into that, because it all comes down to a really straightforward two-step fix that totally changes how the AI learns.
The whole process really boils down to just these two things: clipping gradients and adding noise. Now, I know they sound super technical, but trust me, they're actually really elegant ways to solve that memorization problem we talked about. Let's break them down. Okay, first up, clipping gradients. So in AI training, a gradient is basically the signal each piece of data sends to the model, telling it how to adjust itself. By clipping it, we're basically putting a volume limit on that signal. This makes sure that no single unique piece of data, like your specific record, can shout louder than anyone else and have too much influence. It stops the AI from obsessing over and memorizing any one person's info.
Then you've got the second step, which is adding noise. And this is pretty much exactly what it sounds like. We intentionally mix in a small amount of random mathematical static into the data while the AI is training. This basically acts like camouflage, blurring the fine details of any individual data point.
I absolutely love this next analogy because it just makes the whole concept click. Adding noise is like dropping a single drop of ink into a giant swimming pool. Now, the overall color of the water might change just a tiny, tiny bit, so the model can still learn from the data as a whole, but it becomes impossible for anyone to find or point to that original single drop of ink. Your beta just dissolves into the crowd.
So the result of putting these two steps together is huge. With your data's influence capped and its details blurred by all that noise, you get this incredibly strong privacy guarantee. It becomes statistically impossible for anyone, even the people running the model, to ever know for sure if your specific data was in there or not. Your privacy is now mathematically protected.
So this sounds perfect, a magic bullet, right? Well, as with most things in technology, there's a catch. There's always a trade-off. Adding all this noise to protect privacy can have a side effect, which brings us to the big privacy versus accuracy debate. And this chart lays out that tension perfectly. See, on one hand, if you want more privacy, you've got to add more noise. But if you add too much, you risk blurring the very patterns the AI is supposed to learn from, which can hurt its accuracy. But then, if you aim for maximum accuracy and use less noise, your privacy shield gets weaker. It's this constant balancing act you have to manage. But here's the twist, and this is what makes this whole thing so viable. You'd think that trade-off would be a deal breaker, right? But it turns out that these massive AI models, the huge language models we use today, are surprisingly tough. Because they're trained on such an enormous amount of data, they can still pick out the important, broad patterns, even with all that static. They can basically see right past the blur and still be incredibly accurate.
So, we've got a tricky problem and a really clever solution. But let's pull back for a second and bring this into the real world. Why is this so critically important right now?
Well, because this is where the stakes get unbelievably high. Just think about sectors like healthcare or finance or sensitive government data. In these areas, using AI has the potential for incredible breakthroughs. But leaking even one single patient record, one bank account, or one citizen's file, that would be an absolute disaster. For these fields, differential privacy isn't just a nice-to-have. It's absolutely essential.
So, let's just boil this all down. The first part of the bottom line is crystal clear. As AI gets woven into everything we do, training it on our sensitive personal data without some kind of ironclad protection is just way too risky. The potential for leaks is real.
And here's the second, more hopeful part of the bottom line. We have a powerful tool to manage that risk. Differential privacy gives us that mathematical shield we need to keep our secrets safe. And crucially, it can do it without totally crippling the performance of the giant AI models that are changing our world. Which leaves us with one final and I think provocative question to chew on. We have the technology to protect our data. We know it works. So should using it be optional? Or should companies be required by law to use techniques like differential privacy whenever they train an AI on our personal information? That's a big one to think about. Thanks so much for tuning in.